Mojaji, you don't have data in Excel.
Morning, Doc. I do have, but remember it was missing some years. So I've gone back to request additional years.
Okay,
So I've
so
only got
the
20.
one that you have,
Yeah,
which lacks some years, have you sent it to me?
I haven't sent it. No, not yet, Doc.
Yeah, it's always good, guys, that you send me your data so that I have a look at it before you even top up. Because when I look at it, I'll be able to know that there are some missing variables. So you should add the variables. More, do you have your data?
Hi, sir. No, I don't at the moment. I was in hospital the past week, so I'm a bit behind.
Do you know your
However,
data you have to collect?
sir?
Do you know the data you have to collect? Do you have an
Yes,
idea of what data you're collecting?
yes, sir, we did go through it the last time. So it's just that I haven't really started with it because I was sick. However, I'm going to proceed this week with it.
All
So I'll
right,
just keep updating you as I go.
okay. So guys, please note that without having your data, you have no thesis. Without having the data, you cannot answer any of the research questions. You cannot answer any of the dilemma questions. You cannot address the objective. And I think you probably would know that from day one, I have been mentioning, get your data ready. So I'm going to teach you something today as if you have the data ready. And so I will make a certain data. I have already given you that data in the group page. Please, if you haven't, especially the last one I did, if you haven't downloaded it, please download it. If you haven't downloaded and opened it, especially the Brukutu data set. Let me show you what I mean. So the data sets that I sent you, the last one that I sent you is this on your screen. I'll use this to demonstrate everything about regression. I'm going to show you everything about regression. Please take note. Have a pen, have a paper, have a book. That way, you'll be able to capture some quick things instead of going to go into your video to watch before you remember some things. At least now that you are here, once you are here, you are here. Once you are here, you are here. So at least now that you are here, please make good use of your presence and take some notes. Write some equations. I'll be giving you some equations. Write them. Take some notes as well. Whilst you write some equations, it will help you big time. Okay. Before we do regression, and because you are going to do this for your own data, you see, you're going to do this yourself. I am going to do it here. But when you get your data, you will do it yourself. So that is why the data I am going to use here, I have also given you that data. Before we look at regression, before you even ever do your regression, there are certain things you have to do. Now today, what I'm going to do is I'm going to demonstrate how you can use Excel to do those certain things. before you undertake regression. And please remember that the regression that you are doing is a technique. It's a technique. It's a statistical technique that you use to address research questions. It's an approach that will help you to achieve an objective of a research. There are several ones. Regression is one of those techniques. It's used in artificial intelligence, machine learning, robotic engineering, is used in economics and several things. But there are other techniques. Some are better than regression, some are not better than regression. But before you undertake regression, which I will teach you, before we even come to the regression, once you get your data, you're supposed to arrange your data in a way that is beautifully organized. And I'm going to show you an example of what I mean. So I'm going to create a new column here. I hope you all know about Excel, right? If you don't know about Excel, please raise your hand and let me be sure that you've never used it before. That way I know how to proceed. Okay, good. I'm going to create a column and show you how the data needs to be organized. By the way, this data I'm using, the instruction about this data is already in your, I have already given it to you in your, what do you call it? In your work. I've sent it to you in your work. Now, in case you probably don't remember it, let me just give you a bit of information about this data. So I'm just showing you that the data is known as Burkutu. What is Burkutu? It's just a local gin distillery. And I've sent you this document, so you will know about this document. This is the Burkutu here. It's a local gin distillery. Please, do you see my data, my screen?
Yes, Prof.
Yes, we are.
Okay. So this is a kind of a company that produces alcoholic beverages. And demand, I'm telling you the story. The same thing when you get your data, you need to tell the reader a bit about your data. Demand for most of these retail shops have been hard hit because of new entrants into the market. There's a lot of competition. And so management is concerned that a competition can destabilize their progress. So they want to determine which factors, which predictors will come to this word, which predictors, which independent variables, which features, which explanatory variables, which confounding variables. Which of these factors will better explain the quantity demanded of their gin? Which of these will better explain the quantity demanded of their alcoholic beverage? Whether people will demand will depend on price. They know that already. That if the price is too high, what will happen to the quantity demanded? I need some quick answers so that we can flow quickly because this is not going to be anything.
Demand will go down.
Demand what?
It's reduced.
Demand will decrease.
It will decrease, exactly. So price is one of the determinants of demand. Out of that price, there are other factors, other predictors, other independent variables, other, explanatory variables that can also affect the quantity demanded aside the price. One of them is the price of a complement of the gin. For example, if you are drinking alcoholic gin, sometimes it goes with other complements. For example, you take along with barbecue. If you have barbecue beside and you have your, I mean, Mojaji, you are good at these things, aren't you?
Very good. Thanks, Doc.
Exactly. See, I know the people that are good. So if you have your alcoholic wine or whiskey or anything, and you are taking it, it will go with some kebab. What else does it go with? What are the other complements?
With ribs, Doc.
What?
Ribs.
Ribs. Okay. Okay. Jonathan, what does it go with? Give me some. Give me some.
Yeah, anything. Chicken,
You have
meat,
been
lamb
drinking it, so don't
chops,
say anything.
milk. Yeah. So, but I just couldn't unmute. I would say depend, maybe because it's alcohol. Price depends on the elasticity of it, because
You are being
I
complex.
mean,
Let's come
South
home. You are being
Africa.
too complex, my dear friend.
I'm
Let's
just
come
saying, in
home.
South Africa, the price can double. We'll still drink it, and we'll still consume the
Of course,
same
of
or
course.
even more.
I want you to know that every factor we are picking here is not absolutely true. Everything is not absolutely true. We are looking at the generalization of the thing. We are even considering the gin as a normal good. We are not even considering it as a luxury good. It's not top level whiskey. We are not considering it also as an inferior good. We're considering it as a normal good. Normal things. Normal things. When the prices are so high, you will switch away from that. That is why if you increase the price of fuel too much, what do you think people will do? They will not use their cars. They will park their cars. And then what do you think they will do? They will go and take the bus or the train. Is that not what happens? Normal goods. However, if the good is ostentatious goods, luxury goods, if you increase the price, people will still buy more, like diamond. If somebody comes to you and tells you that he has a price of a diamond and the price is $4, you won't buy. Because such goods are luxury goods. So those goods, they go against the law of demand. But that's not what we're looking at here. So don't think too much. Think normally. The ordinary person, if the prices of certain normal goods, unless the good is essential, like food, even if they increase the price, you have no choice, you have to buy. Essential. Those ones are different. But normal goods. Okay. So for normal goods, if the price of the complement should go up, for example, if you take kebab, which goes with alcohol, specifically gin, if the price of kebab should go up significantly by, say, 1,000%, people will not buy that kebab. And because normally the kebab will go along with the alcohol, they are likely to reduce their alcohol consumption. These are likelihoods. Another factor is the average income of the people. If the people have, ordinary people, all right, if their income should go up, what do you think they will do to the quantity of gin?
It goes up.
More consumption.
More consumption. Now let's go. This is a
Yes.
data set, by the way. This is a data set. Okay. So we have spoken about the price. Okay. We have spoken about the complement. You see the way I've labeled it? We have spoken about the average income of the people. So your data must be well arranged. This is just 1 year data. Just 1 year. If I go to the Excel, okay, if I were to put something here, I can call it like a shop. Let me create another one and show you. So this is just a 1 year data, where here you have something like the shop. Okay. So the shop can be, in your case, if you are dealing with country, it will be a country. In your case, if you are dealing with banks, it will be bank. So we can say that shop 1. See what I'm doing? This is practical hands-on. And then we can do shop 2. as you can see. And then I can just populate it, double click, and then have it all for all of them up to the end. And then you have shop 40. So you now have the names of the shop here. And let's put the year here. So because we are dealing with just 1 year, let's say 2001, you can just have 2001 all through. I hope it doesn't populate. So this is 2001. So we are just looking at 1 year data. That's it. If you are dealing with panel data, which is on calculator, if you are dealing with panel data, it means that you're going to have the same thing for all of these, but for 2002 and for 2003 and for 2004. But for now, we're just looking at 2001. And then the names of the companies or the names of the countries or the names of the stores or the names of the shop are on the far left section. Now, the major variable is the quantity demanded of gym bitters, which you have in the first column. Then you have the price of gym bitters itself, which you also have some theoretical belief that this price can affect the quantity demanded. Then you have the complement price. Then you have the income. All of these are numbers, are they not? They are numerical. They are numerical. Please remember, there are two kinds of data you can ever collect: numerical and categorical. Did any of you collect categorical variable? Is any of you collecting that? Work along with me, work along with me, work along with me.
No, all numerical.
Do you know what I mean by categorical, by the way?
It's descriptive.
So in your data, you are not taking things like the ownership, the type of a bank, whether it's foreign or domestic. You are not identifying anything.
No.
I do.
In those of you who are doing countries, in your data, you are not doing anything like whether the country is within ECOWAS or SADC or anything. You're not having economic bloc to define it. In your groups, you don't have any group of things. You don't have any local. That's what I mean, man.
Yeah, Doc, I think for me, it's an afterthought. I've done it separate, but I just need to add it on the same spreadsheet.
Well, that's, you see, I'm not just teaching you guys, right? I'm applying the teaching that we are doing. So take note. All right. So these last three are the categorical variables. Sometimes they are called dummy variables. Okay. If you go to the story, you would have known what it's talking about there. It says that the quantity demanded of gym bitters, apart from the price, the complement price, and the income, it also depends on the location of the shop. Okay. Whether the shop is located in an urban or in a rural area. If it is located in an urban area, let's give it a value of 1. That's a dummy code. If it is located in a rural area, let's give it a value of 0. The other factor is, apart from location, is occupation of the people. And in this very, very example, I have listed 3 kinds of occupation. If the people are teachers or fishers or traders, that would determine the quantity demanded of gym that they will consume. Which of them do you think, just on top of your head, do you think they are more likely to consume more alcohol? Which of them? Which of these occupational groups?
Yeah, teachers working with kids, or we actually your kids. So after this,
Well,
we're
you know
going
a
to
teacher who
consume.
gets drunk most of the time, right?
I think fishing.
I also think fishers. I think teaching seems to be a bit more polished relatively, I mean, in particularly in Africa, for them to be known to be even drinking this, not whiskey. Remember, we are talking about the very local gin. So most of the time is the fishers followed by the traders before the teachers. Because the fishers can actually easily drink even on the job. Traders, yeah, but teachers, the nature of the job require that you have to be careful. I mean, you can debate it. The other part is religion. Religion can also affect the quantity demanded. So you see, you must have some idea of variables that are likely to affect or influence the dependent variable. And you're going to learn, not now, you're going to learn later on that in a regression, there are two kinds of variables, the dependent variable and then the independent variable. In case you have not written these things down, you got to write it down. The dependent variable is simply influenced by the independent variable. The independent variable influences the dependent variable. We assume that the independent variable is exogenous at the very least, meaning that we are assuming that it is not being influenced by anything, even though it may be influenced by something, but not known yet. But we assume that it is exogenous, not influenced by anything. And because it's not influenced by anything, its impact on the dependent variable, in this case, the dependent variable is the quantity demanded of them. Its influence on that dependent variable will be unique. It will be unique. It will be special. It will be soul. It will not be intermingled or mixed up with other things. Otherwise, there will be something we call indigeneity. I'll come back to that later. But please note that these are other factors. Okay? These are other factors that are presumed. So if you take religion, there is the belief that the type of religion that you belong to may influence, are likely to influence your alcoholic consumption. Do you agree with that?
Yes.
So which one is more likely to be increasing alcoholic consumption? Which of these religious groups?
Christian.
Why?
I think Muslims and Buddhists don't really drink that much. You can correct me if I'm wrong.
Uh-huh.
I think Christians are more bound to drink more than
I agree with you.
Muslims and Buddhists.
I agree with you. So Christians are more likely. The question is whether that is true in your analysis you're about to do. When we shall check whether Christians are boozers more than Buddhists or not. All of these are categorical variables because they have different categories or groups within it. So when you take occupation, you have different categories. When you take religion, you have different categories. When you take location, you have different categories. And one of these categories will usually be the baseline. We call it the reference group. So teaching, fishing, trading, one of them will be the baseline. So when you are talking, you will not mention that one will not be part of the data. But anytime you mention the other one, it is in reference to that one. That's what we mean by regression analysis. So it includes dummy variable. Some of you may include dummy variable. Okay, so with that in mind, you have a feel of your data. And that is what I mean by when you collect your data, you are supposed to explain to the reader, the first column called GDP is the GDP of the country measured in blah, 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 blah. This is the total basket of blah, blah. You explain your data. Let the reader know that you know what your data is about. Each variable, you got to know about it and explain the variable. And that is why you can't just let You can't just send me something. You should be able to take column by column. So when you go to my column here, column by column, each one must be clearly shown. Now, if you look at the bottom of my screen, I have opened the sheet called Brukutu R, but there's another sheet called Brukutu for Excel. It's the same data, but what I have done is that I have coded these numbers. Okay, urban, rural, urban, rural. I've coded that wherever you see urban, make it 1, so that we'll have codes. Wherever you see rural, make it 0. So when you come here to this coded version, I've created a column instead of the location or log. I have called it LU. LU means that wherever you see urban, code it as 1. Wherever you see rural, code it as 2. In terms of the occupation, I have coded one column to be occupation for teaching. Wherever you see a teaching, code it as 1. Everything else, code it as 0. Wherever you see teaching, code it as 1. Everything else, code it as 0. And then for the other occupation, I called it trading. That means that once I have taken teaching and trading, the last occupation, which is fishing, will become the reference category. I will not have to do anything with that because that becomes a 0. So occupation trading is done in this way. You see, what I'm doing is I'm helping you to also fill your data. So when you take your data, feel it, understand every word, every number, every full stop, every comma, everything of the data. You got to have it clear in your hand. And then, wherever you see trading, code it as 1. Anything aside trading, 0. Then religion, there were 3 of them. So you have to do a coding for 2. So anytime you have 3 levels, the dummy becomes 1 less. So if you have 3 levels or 3 groups, the dummy becomes 2 groups. If you have 4 groups, the dummy becomes 2. If you have 4, the dummy becomes 3. If you have 7 groups, the dummy becomes 6. If you have 10 groups under one thing, the dummy becomes 9. So the dummy is always 1 less than the groups. Yeah, reviewer.
Good afternoon, evening, sorry. Prof. So just a quick one. So if you've got multiple, so in this case, right, let's say for gender, no, so I've got categorical variables that have got like 5 or 6. Let's say
It's got 5 or 6 levels.
Yeah, so let's say like a role in the bank. Remember, so just to give you an idea, my questionnaire has got what type of level are you in the banking? Are you like an operator specialist, a junior manager, senior manager, executive? How do you represent that? Because I see here when you are the other, not this, the document that
Is that going to be your major variable? Is that going to be one of your major variables?
Not really, no.
Yeah, then you don't need it to create a variable column for it. Okay, because I think your questionnaire, what you are doing is that you are using your questionnaire to come out with an index, isn't it?
Yes, yes.
So everything that you come out, what you rather would need here is the index. And the index will be a numerical variable. It will not be a categorical.
Okay, got it.
Yeah. You are dealing with what? Banks or people?
Say that again, Doc.
Your major, your subject of study, are you dealing with banks or individual human beings?
With banks.
So in this case,
with banks, but collecting the data through people.
Yeah, but then we agree that your people then becomes a representation of the bank, isn't it? Even though you will anonymize it.
Correct.
Correct. So it's still bank. Bank is still the focus here. So in this case, your first column here is going to be bank. So if you want to talk about any categorical variable, is either going to be some things like whether the bank is a local bank or a foreign bank. Or you are going to think about whether the bank is a small bank, a medium bank, or a big bank. These are possible categorical creations. Or whether the bank is a multinational or it's not a multinational. You know, those are the possible categorical variables you might get in your work. Other than that, you're not going to get anything.
Okay, noted. Thank you.
Okay, guys, ask questions. Remember, ask as many questions as you can because this is a lifeline. Okay, so this is the data set. I have the coded version. And by the way, Excel can easily do this coding for you. R can do this coding for you. Python can do this coding for you. It's easy. Once you are done with the coding and you have the data ready, you see, some people would have collected this data. But let me just take this one here. Some people would have collected this data. Some people, what they would have done is that they would have collected this data and manually typed them in. It's not easy for some people. They would have manually typed the entire data set into the work. They would have done that. And that is going to be tough. But for some of you, what you are going to do is you are going to get the data given to you freely. And so that is really cool. That is really cool. However, whichever one it is, you must get the data ready like this. This is what I mean by the data must always be ready. You see, I've spoken a lot about you must get the data ready. So I'm going to work assume. You see, so when I'm doing the regression, don't start saying that, oh, but I don't have my data, so I don't know what you're talking about. I'm working, I'm talking as if you already have the data. Okay, so now that you have the data properly organized, the dependent variable is the first one. Okay. Now, how do you analyze the data? This is the data analysis section. There are actually like 5 things that you got to do with the data. Okay. There's so many things actually, but I've categorized them into 5. One of the major things is that have a feel of your data. Look at the time of your data. If you have multiple times, look at how the data is changing over time. And how do you check whether you just click on the data and then go to insert and then take a time graph like this, okay? Time graph. Suppose this one's on the horizontal axis is time. You can plot the data. Okay. Suppose what is down here is 2001, 2002, 2003. You can plot the data like you see I have done. And then you can see whether there was a hip or a drop. There was a big sharp rise or a big sharp fall in the data. If you look at what I have here, everything is kind of blah, 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 blah. It's just stabilized. Okay. So you can have a feel of the data using a line graph. And this will guide you to know, for some of the years. For example, during that particular year, there was a financial crisis. Oh, that's why things are down. During that year, there was a COVID-19. Oh, that's why things are down. Okay. So you will be able to have a feel of the data using a graph. That is not the only graph. There's another graph you can have. You can just scatter plot some of the data. So when you go here, you can scatter plot some of the data to have a feel of the data. You can do a graph of the data. This is a bar chart of the data. It gives you a feel of the distribution of the data. You can do so many things, to be honest with you. You can do this. It's called box plot. To be honest, you can click on this corner here, and then it will give you several possible graphs that you can do. So when you click here, like, all of that, you can have a feel of what data you want to analyze. And sometimes you don't have to highlight the title, just highlight the numbers, like I'm just doing now. And then by highlighting the numbers, this is a pie chart, it's no longer necessary. This is a combo plot. You have the opportunity to explore. Okay. You have the opportunity to explore, to have a feel of the data that you are looking for. So if you want to do the radar map, this is it. You want to do XY plot, so this is a scatter plot, bar chart, area plot, line. Some of them will tell you something. That's a whole visualization program that you can apply. You can also establish the possible relationship between price and quantity. So for example, you can do price and quantity like this. So I just want to see the relationship between price and quantity demanded. And we know that in this case, it's supposed to be negative. So you check that with a scatter plot. So this is a scatter plot. Okay, I just did. And you go to quick layout here. They choose layout number 9. It quickly gives you a regression. But more importantly, you can see that the line is beautiful. It tells you clearly why is this thing? Anyway, so it gives you a feel of the data. You can label the axis yourself. Okay? And it tells you that truly there is a negative relationship between that. And you can see the regression line showing that negative. And you see the equation is even showing that there's a negative relationship between Y and X. In this case, Y is the kill, the X is the price. So this scatter plot gives you a quick idea of that. If your scatter plot is not giving you expected look, then you may have to take the log, the square, or something, the square root of some of the variables. You may have to take the natural log of some of the variables. We'll come to that next time. And then you can look at how it goes. I'm deleting this. Yeah, reviewer.
Quick one, Doc. So is it easier to work? I've had a bit more experience from a data science perspective working with.
Sorry, I can't hear what you're saying.
Can you hear me?
Yeah, now it's better.
Now, I'm saying I've had a bit more experience working with on notebooks with Python for data analysis. Do you find that it's easier using that, or you'd still say Excel is better?
Well, I just mentioned that. I just mentioned before I started, maybe you weren't here. I said that not everybody is advanced. So I'm starting with the Excel. But Excel is very limited. I will now go from Excel to R to Python so that whichever one that you are comfortable with, you can. Now, Python and R are very matured, but there are some things Excel can do quickly for you that you don't need to go and then start writing all of those codes. So if you can quickly show something, because most of our data normally come from Excel in the first place anyway. So once you have the data in the Excel and Excel can quickly do some quick visualizations or analysis, why not? You start with Excel. Then later on, you can go ahead and use Python to check. But if Excel cannot do that, for example, Excel cannot do things like violin plots. You know, it will not effectively probably do things like box plot, things like, there are some major things that it might not be able to do. For example, principal component analysis, it will never be able to do that. And Python can beautifully do that. So it depends on what you want to do. So you can, if you are comfortable with Python, you don't even need to do this. You just go and code everything into your Python. But I'm teaching different categories of people. So I want everybody to have a feel of what you can do. And I will later come and use this thing also in Python. There you see. All right, so those are some of the fields that you can do. You can do a scatter plot of some of the things. A scatter plot means that you're just dealing with two variables. So you can highlight only Q and C. This time you are not taking P, okay, because unless you want to do 3D graph, which Excel cannot do, but the others can. And then again, this time you go to scatter plot and you have the scatter plot. You can see that in terms of the complement price, it's rather positive looking. And if you choose the layout and you do the regression line, you can see clearly that it is truly positive looking. Okay. So it means that there's a positive relationship between the complement price, the complement, and the quantity demanded. So if the price of the complement should what do you call it? If the quantity of the complement should go, if the price of the quantity, if the price of the commodity, actually the price of the gin, if it should increase, you will reduce the quantity demanded. Okay, or let's put it, if it falls, you will increase the quantity demanded of gin bitters. And now that you've increased the quantity demanded of gin bitters, you would also want to increase the quantity of its complement, because the complement go along with the commodity itself. So if it is kebab, now that you are buying more of gin, alcohol, you buy more of kebab. So you have a positive relationship. I think this thing is supposed to be complement itself, the quantity of complement, the number of complement rather than the price of complement. Okay, so you can do a couple of plots. That's for you to explore later on, specifically. It's different from everyone. So that's one of the early birds of things that you might want to do. Okay. The next one, which is the most important reason why I'm here, early bird things you want to do, is to generate the descriptive statistics of your data. This is key. So once you have your data like this, generate the descriptive statistics. And you can see that in this very example, in this Excel example, Excel cannot generate descriptive statistics for categorical variables like you have here, for location, occupation, and religion. It cannot do that. So if you are taking notes, descriptive statistics is very key. Very, very, very key. Very key. So you have to, in this very example, I'm going to use the coded data to generate the descriptive statistics. How do you do it? In Excel, you can easily do this. Okay. Click on the data tab at the top. If you don't have the data tab, it means that you have to go to File on the far left, choose Options at the bottom left. The Excel parameter dialog box will come. Select Add-ins. Why is it delaying? Hold on, it's delaying a bit. Anyway, you select Add-ins. That's it. And then choose Analysis Toolpack at the top. Come down, select Go. And then the Analysis Add-ins parameter dialog box will pop like this. In the list, you check the Analysis Toolpack, that little box on the left. Check it and click OK. And now, when you click on the Data tab, on the far right, you should see Data Analysis on the far right. You should see Data Analysis here. Okay. So once you see the Data Analysis, you now click on it. And in that Data Analysis, as the name sounds, it has a lot of analysis it can do for you. Okay. There are several things. If you are doing ANOVA, correlation, covariance, descriptive statistics, what we're about to do, exponential smoothing, a Fourier analysis, histogram. So if you want to draw a histogram, moving average, random, regression, okay, sampling, t-test, z-test, all of that. But my focus is to do descriptive statistics here. So you double click on the descriptive statistics, and then a box will appear. In this box, your work is basically to select all of the variables. So click at the top of the queue, don't include the year, and then drag it to the right to the end of the variable. Drag all of them down into the data set. When you exceed, come back. That is the input range. Then you select labels in the first row because you selected the first row. Then click on the output range. Click on the white space to the right of the output range. That white box to the right of the output range. The cursor will be blinking there. Then you just select any empty cell you want to show your descriptive statistics. Then select at the bottom summary statistics. Summary statistics is the same as descriptive statistics. Then you click OK. It will generate the mean, the median, the mode, all of those things that you need for your descriptive statistics. Please note, there are 5 major, if not 4, there are 5 major things that you basically need when you are doing descriptive statistics. Okay. Now I'll talk about them, but before that, let me arrange this thing. You see, each column has got mean, and the rest, and that becomes too tautological. So what I want to do is I want to just delete some of them. To do that, I'll just pick all of this, cut, Control X to cut, paste it in the next column. Okay. And then now I can click on each one of these and then delete. Okay, so watch, I click on it, hold the Control key down, keep holding the Control key, keep holding the Control key, keep holding the Control key, keep holding, because they are all the same thing being written. Okay. And then when you are done, you right click on one of them at the very top and choose delete. Choose delete. Once you do that, everything is deleted. The data is now plotted nicely. Okay. Now you can see that for quantity, the mean is 175. The major variables you need are the following, the mean. So you need to record the mean. In some cases, you need a median. Okay. In some cases, not in some cases, you always need a standard deviation. Okay. In some specific cases, you might need a kurtosis or the skewness, especially when you are dealing with financial data. Then you need the minimum and the maximum values. If your data is large and you want to show the sample size, you might need the count. Other than that, if you mention in your work that the number of observations I have in this case are just 40, then that's okay. That's okay. Okay. Other than that, you don't need that 40 because they are all 40 anyway. So you can just say it as a 1 cent. And then these variables I've highlighted is what you are going to take into your Word document, your thesis document. Now, I can take it like this. Watch it. I can just copy like that. Control C to copy. Go to your Microsoft Word. So let's say that you have your chapter. Okay, you have been saying so many things. I'm just assuming that I'm saying so many things here. Okay, good. So you have typed a lot of things, and now you want to insert this table. Watch it. You click this table, you insert it, but you don't want these columns. Okay, so I'm trying to pick on the columns I don't want. I don't want all of these columns. I don't want all of these columns. I don't want this, even counts. I want to delete count. Okay, you just do that, and then you can just select delete, or you can just do backspace. Hold on. I'm trying to delete. Oh, it's gone. Oh, it's not coming. All right. So what I'm going to do is I'm going to do it in Excel. I mean, you can do it here, but then it's just annoying me. So what I'm going to do is that I'm just creating a new sheet in Excel and just pasting it and just trying to delete each other. I'm picking on each one of them, and then I'm just going to delete. Okay. Now, because I deleted the count, the last bottom horizontal line is gone. So I'm just going to not delete the count for now. And then just delete the rest. Because that last horizontal line is beautiful. So you can have something like this. Now it is nicely put together. Okay. If you don't want the median is usually used when you have efficiency scores. If you don't have efficiency scores, you don't need the median. So I'm just assuming that we don't need the median now. So I delete the median as well. Okay. And then I will now pick on this. Okay. I'll now take this data table, go to your Word document. So let's assume that you've typed all the mumbo jumbles. Okay. You come to your Word document, and then you paste it here, as you can see. Okay. You paste it. Now, some of them have moved to the right. So if you want to properly arrange them, you can always right-click and then auto-fit content. Now it looks very, very cool. This standard deviation has taken a bit of a space, so you can just make it SD for standard deviation. SD. So the minimum is also taking space, so you can just make it MIN dot. The maximum has taken space, you can make it MIN, MAX as well with a dot. As for the count is a sample size, so you can just say N, sample size. So you can see that now this table looks good. How do you label tables? In your work, this is how you label tables. Write table and then write the number. Write table, then the number. Okay. Bolding it, but the title of the table. For this one, the title of the table is summary statistics or summary of variables. So you can just make it like that. And then just bolding the work table one. Then you have the title below. Tables, the titles are above. Figures, the titles are below. Take note. Figures, the titles are below. So this is it. This is a mean. So you can make it look good by moving this thing a bit. Yeah. So that's it. This table now looks good. You can now talk about the mean and say that the mean of the quantity demanded is 175. Okay. And that of the complement is 125, and blah, 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 and blah, 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 blah. That's for write-up. So you have the table to show. This is how you generate a descriptive statistics. Any question? And you must all have it. You must all have it for each of your variables. Because you're not going to be dumping your entire Excel to anybody. What's his name? Twala, are you the one who said you sent me the work? Or it is Dimisani?
Yes, it's Dimisani.
So can you do the descriptive for this?
Yeah, I've done it last night here, Doc.
Okay. So that is how you do it. Now, so this is a basic thing that you should all do. Mojaji, you should be able to do this, right?
I'll be able to do it, Doc.
The next thing, and this is all before the regression, okay? The next thing is correlation. Because you are going to look at, causality later, which is a regression. Regression is all about causality, causal relationship, cause and effect. Because we're going to look at that later, it will be nice to establish correlation. It will be nice. Now, you can create correlation matrix, and then you can also check the p-value. The p-values and all of those things. When I say check the p-values, I mean check whether any correlation is significant. But what do we mean by correlation? Correlation is when you want to look at the association between two variables. Some few minutes ago, I showed you the association between price and quantity demanded. And how did I do it? I used graph. So what I did is I used this thing, I went to the scatter plot, I showed the scatter plot, and then after showing the scatter plots, I went to quick layout and generated a kind of a regression line in between them. Like this. Of course, you can click anything else you want to click, and then add any other information you want to do. You can delete the legend, you can delete the title, because all of these things, you will need them. And then on this axis, you can have the price of gin. Okay, use a proper name, price of gin. And then on the y-axis is a quantity demanded of gin. So you can just write quantity demanded. And that's it. So now you've labeled the axis very nicely. Okay. Now it is already showing a correlation. I'll come back to that. It's showing a correlation. Then you take this data, copy, go to your Word document. This time it's not a table, it's a figure. So you paste like this. Then below the figure, write fig, F-I-G dot 1. That's the name of the figure. Then you give a space and then type, let's say correlation scatter plot of price and quantity demanded. Quantity demanded. Scatter plots of price and quantity demanded. That's it. So you can see that since it's a figure, I have brought it below. All right. Now, this is just a graph. The good thing about Python and R is that it can do a graph of all of them into one. You call it a scatter plot matrix. When we get there, you see it. But then Excel can't do that. So Excel will have to do one by one, just two variables at a time, two variables at a time, two variables at a time. But scatter plot will do two variables at a time, but all of them at a go. That is what Python would do or R will do. Okay. Now, how do you find the correlation? So what is correlation in the first place? I am taking this scatter plot, I'm moving it to the right, okay, because it's not too important for now. What is correlation? For your information, correlation measures the relationship between two variables. Two variables for now. It measures the relationship. It doesn't tell you what is causing the relationship. It does not tell you about causality. It doesn't tell you what is behind that relationship. It only tells you that there is a relationship, whether that relationship is positive or negative, and then the value of the relationship in percentage terms. And of course, the higher the percentage value, the greater the correlation, the stronger the correlation. If the correlation coefficient, and we call it Pearson's product moment correlation coefficient, Pearson's product moment correlation coefficient. The document I've given you, the PDF I've given you, it has all of those. So you'll be able to calculate the correlation coefficient. If it is negative 0.4, it means that the correlation between the two variables is 40%, and it is negative, meaning that as one is increasing, the other is also increasing. I didn't say that one is driving the other to increase, but the thing is that as one is increasing, the other is increasing. Now, let me ask you guys. Suppose you have two correlations, okay? One of the correlation is negative 0.85. The other correlation is 0.72. Which one shows a stronger correlation? Which of these two shows a stronger correlation?
0.85, Doc.
Which one?
0.85.
Why?
We're looking at the absolute value.
Very good. I think you've watched good videos, so that's good. Okay. So that is it. So the strength of the correlation is not determined by the positivity or the negativity. It is determined by the absolute value. So it means that this first one has a strong negative correlation than this one, which has a positive correlation. Okay. Whichever the variables are, let's say the variables are X and Y, or let me be very pragmatic. Let's say the variables are quantity demanded and price. It means that there is a 85% relationship that when price is increasing, quantity is also increasing. Correlation is only telling you the relationship, how they behave, how they move. It may not necessarily explain that one is causing the other. Okay. So now that you have an understanding of correlation, I spoke about Pearson's product moment correlation coefficient. Okay, we call it the rho, R-H-O, Greek letter rho, which looks like P. Now you can use that to calculate the correlation value for all of these, assuming that the data is normally distributed. But if the data is not normally distributed, if the data is rather skewed, if the data is rather non-parametric, if the data is rather efficiency scores, if the data is rather something that is not normal, that is probably distribution free, then in that case, you don't use the Pearson's product. You rather use the Spearman rank correlation coefficient. As for this time, oh, and by the way, Excel doesn't have the Spearman. So in that one, you will not have to do it in Excel. But I'm just going to show you how Excel calculates the Pearson for all of them at a go. And I'll use that to create a correlation matrix. So that is the next thing you will create, a correlation matrix. Mujaji, take note of all these. So how do you do that? Go to the top, click on data, and choose on the far right, data analysis. In the list, you see correlation, correlation, correlation. Now, it brings out the box, the correlation parameter dialog box. In that box, you have input range. Input range means list all the variables. We have the variables from Q all the way to RM. You see, remember that in this data set, I'm using the Brukutu Excel. I'm not using the Brukutu R. Because Excel is only requiring the numbers to be numbers, the variables to be numbers, which I have coded. So click on the Q, drag it all the way to RM. That's it. Take labels in the first row. Check the output range, which is where you want your results to be. I want my results to be right below the count. So I'll click there. That's it. Click on tab. Once you click, okay, hold on. I think I made a mistake. Oh yeah, I didn't select the variables well. So go to the input range, delete whatever you have, select the Q, drag it all the way to the end, and drag it all the way down to the end of the data. That's it. Now they are sorted. So you click OK, and the results will show in L16. So here's the results. You have some beautiful results, but the decimals are too many. So in order to change the decimals, click on the Home tab, and then choose just in here, choose under this, in my case, under Help or Power Pivot. You see this General. Click on the General. There's a little arrow there and choose Number. It will bring everything to 2 decimal places. I did that while the results were still highlighted. Now you have the correlation matrix. It's beautiful. It's beautiful. Twala, have you also done this, or do Miss Annie, have you also generated this?
No, not yet, Doc.
So this one, I'm just giving it a color so that I can. So this can give you a feel of the relationship. Okay, there are so many things you can deduce from here, but one of the things is that when you use Excel, it doesn't give you whether the correlation is significant or not. But when you use R and Python, it will tell you whether the correlation is significant. Look at the price. Look at the price. The correlation between price and quantity is given by negative 0.87. That's how you read it. So whatever is on this left vertical is the same thing that is on the horizontal. So when you pick a variable on the vertical line and then you match it on the variable on the horizontal line, whatever number they meet, that number is the correlation coefficient. You will notice that all the numbers on the diagonal, here are all 1, 1, 1, 1, 1, 1, 1, 1. Every number on the diagonal is showing 1. Why? Because the correlation is said to be perfect between you and your cell. Correlation between Q and Q is perfect because it shows a correlation between a cell. The correlation between P and P is also perfect. That's why it's 100%. The correlation between C and C is also 100%. So we call them perfect correlation. We don't normally talk about it. What we talk about most of the time is the first column. If we know that quantity demanded, which is Q, if we know that this is our dependent variable, as we know, because that is the one being influenced by all the others, then your focus is going to be on that dependent variable. Please note, if you are doing efficiency analysis, this correlation, it has inputs and outputs. It doesn't have dependent variable and independent variable. It has inputs and outputs. And the inputs are many, and the outputs are many. So in that case, what you are doing is that you are checking the relationship between each input and the output. Each input and output, not among the inputs, not among the outputs, but between input and output. This is called isotonicity test. And so if you're doing efficiency analysis, you have to do quickly that isotonicity test. Yeah, maybe I'll do that with you when you get there. But this is a regression analysis, so we are doing a correlation analysis. So what does this mean? This means that there's a strong negative correlation between price and quantity demanded. It's negative. It's negative, which goes for the law of demand. The higher the price, the lower the quantity demanded. The lower the price, the higher the quantity demanded. So this gives you a strong idea that there is some sort of association. Of course, it doesn't necessarily indicate that there is causality, but at least there is some association. Also, it doesn't tell us whether it's significant or not because we are not using Python or R to indicate that. All the others are positive. Some of them are also negative correlation. Okay? Negative correlation. Now, please remember that we don't normally talk much about these ones, which are the dummy variables or the categorical variables. We don't really discuss them much. Why? The reason is because they are static variables. Remember, dummy variables are static. If you are a teacher in that village or anything, at least within a year, you are still a teacher. You are not changing every year from being a teacher to a doctor to a lawyer. Every year you are changing, every year. So there are some variables, categorical variables are usually static. If you're a male, you're generally a male every year, generally. If you're a female, you're generally a female every year. So we don't look at much of these variables in terms of correlation. Okay, in terms of correlation. For example, what is the association between being a female and that. I mean, so we don't normally talk about the categories, but then the numerical variables are key. There's another reason why we don't talk about the categories. You can check that in the video. All right. So this, you have to talk about it very briefly, indicate that it appears that our data satisfies the assumptions of correlation. And at this stage, you can go ahead and proceed with the regression. Now you have to take this correlation to the table. You must take it there. And how do you do that? You just copy it as it is. Okay. That's why I've actually converted it to 2 decimal places. Then you go to your Word document. Remember, we haven't forgotten about our Word document. Okay, there you go. Then you can now right-click here and then auto-fit the contents. Now it looks very, very nice. I can stretch it even further. It is very good. Then you can write on top of it, table 2, because remember, we have table 1 already. Okay. And then below that, you write correlation matrix of all variables. That's it. You have another table beautifully, then you can talk about it briefly. Next one. Once you have generated this correlation matrix, and like I said the last time, once you have generated this thing, you talk about it, whether it's significant or it's not significant, especially when you have used the Python. The next thing is to go and do your regression. But before we do that, and I don't think we'll do that today though, I need to teach you some basic things about regression. And before I do that, any questions so far? Any questions, sir? Okay. There are a lot of things to teach you actually under regression, but I'm going to pick on the basics, but also the more practical, related to what you are doing. One of them is before you do your regression, and I'm going to go to this one here, our data we have been dealing with all this while. Remember that we are looking at cross-sectional regression. We are not looking at time series or panel. But most of you, your data you're going to collect will be panel or longitudinal data. Longitudinal data. That means that your data is collected over years. So 2000, 2001, 2002, not just 1 year like I have here. The one I have, which is just 1 year, which is at a single point in time, is called cross-sectional data. Okay. So one of the first things you got to learn when you are doing regression, provided you have a clear idea of your data and the variables you are collecting. Okay. By the way, when you look at this, everything I've done here today, I've cut and pasted them for you to check. Descriptive statistics, everything. Even the correlation data generated here, you can check it. Oh, by the way, you can also use the correlation to determine something called multicollinearity. I'll come back to that. But I want to just show you something here, which is very important because it's called a specification of the regression model. This is before you even do your analysis. So here's the thing. Specify the Burkutu-Ventures regression model. So whatever regression you're about to do, first of all, you got to know the variables. I think we've spoken about that many times. And pay attention here because I'll expect you all to do yours. What is a regression model? Well, first of all, what is a regression? A regression is just like correlation, but goes way beyond it. Correlation is looking at association. A regression is looking at causality. So a regression is a statistical technique That helps to establish not just the relationship, but the causal relationship. The causal relationship between a dependent variable, which is sometimes called a regressand, and then multiple independent variables. In that case, we are talking about multiple regression. Multiple regression is not the same as simple regression. Simple regression is when the independent variables are only one. So please note, the dependent variable is always a function of the independent variable. When I say it's a function of, that word function of means it depends on, the dependent variable relies on the independent variable or the independent variables. If you are talking about the independent variable, it's only one. So for example, I can talk about quantity being a function of price. But this is a function. I've not written the actual equation or the model. But this one, I can write it properly in a regression model. And this is given by Q. And then you can indicate something called the intercept. And then you can also indicate something called a coefficient or the parameter. And then you can bring your independent variable, and then include something known as the error term. You can bring subscript I for each of the variables, where the I means individual specific. What that means is that you are looking at a cross section. So whatever you are having is not based on time, it's based on the individual. So when you normally collect data on time, that is 2000, 2001, 2002, 2003. When you collect data on multiple years, then when you are formulating your regression model, you have to do based on I, subscript I, and subscript T. In that case, it becomes time dimensional. It depends on time as well. But as you can see here, what you have here depends on just individual I. Now, what does this regression mean? Well, we know already, if you have been doing your readings well, you would notice that this one here is a dependent variable. And this one here is an independent variable. This is a simple regression, take note. And this one on the far right is an error term. There are several names for it. It gets to a point, sometimes it's called the unobserved heterogeneity, the idiosyncratic error. Another common word you will see is the residuals. The residuals. The residuals. Now, what are they for? You've got to have a basic understanding of regression, and that's what I'm trying to show you here. The regression is saying that price influences quantity. And you can do for anything. You can even say that the weather influences sales. So in this case, the weather becomes the price here, the W. So you can say that, suppose you are having sales, okay? The sales is affected by beta naught plus beta 1 weather, okay? Weather. You can write full name of some of them. Okay, and then whether, then you bring subscript I, then UI. Remember the sales is also having I. So in this case, what you're saying is that the weather affects sales. What you're saying above is that sales, what you're saying above here is that price affects quantity demanded. And in this case, you're assuming that only price is doing that. But of course, in the model we have, which is what I'm about to get to, you can see that it wasn't only price. Price is the independent variable. The beta naught here, I was hoping that you will ask me. The beta naught is a constant or the intercept. Why are we bringing it here? Normally, the beta naught has no economic significance, except when you want to do prediction. If you want to use for future prediction, that is when. But then it will be a value Remember, the betas eventually will turn out to be values. So whatever you have in the beta section, eventually we'll have a value for each of these betas. And that's why they are called coefficients. Write it down. Write it down. The coefficient. First of all, the beta naught, we don't know its importance. Like I said, its importance is only during prediction. Other than that, it's for cosmetic purposes. It's for beautification. In fact, Excel even allows you to suppress it so that you can choose not to show it. But when you are in panel regression, during panel data regression, where you've collected data over time, multiple data, big data, that time, this constant, this intercept that you see here, this beta naught becomes useful. We are doing simple regression. That leaves us with two things. What then is the beta 1, which is attached to the price in this case? The beta 1 tells you by how much, write it down. It tells you by how much the independent variable is affecting the dependent variable. For example, let's look at relationship. Okay, you want to look at marriage relationship. You're all married, aren't you? Well, some of you are single, some of you are married. Mo, are you married? Dumisani, are you married?
Yes, Doc.
Mojaji, you are married. You are chilling, so you talk a lot about your kids, right?
I am, yes, sir.
Which of you guys is not married? Linda, are you married? Okay. It looks like some
Not
of
anymore.
Sorry?
I'm saying not anymore. Doc.
Okay. Good. So you are one of the single ones. So you see, when I have data like that, I will have a category where one of the categories becomes married, another category becomes single, another category becomes divorced, another category becomes widowed. So now that becomes one particular dummy variable. But let's look at the marriage relationship. I wanted to use marriage, but now I will use relationship, okay? Because it's not every relationship that is a marriage relationship. So this is a relationship I want to show. In this relationship, the relationship depends on, I can write it's a function of, it depends on several things. I'm sure you all agree that relationship depends on many things. Give me some of the things a relationship depends on. Please don't mention too many abstract things alone. Who can give me one? Quickly. Interact. Somebody has backstage me and said that some of you here, you are not just married, you have multiple marriages. And the person has messaged me privately that some of you have got multiple things going on.
That's not me, Jonathan. Jonathan, is that you?
Well, I'm just saying.
Oh my goodness me. Yeah. He knows what he's talking about. Okay. Polygamy. Okay. So the marriage relationship or the relationship is affected by what? Give me some practice. Quick one. Major one is what?
Love.
Yes, I agree with you. What else?
Communication.
The ladies, that's what they always talk about all the time. Every time I'm teaching this, the ladies will talk about love, communication, love, communication. What else? The men, they talk about something important as well.
Respect.
He's talking about it, respect. I told you, I don't want too many abstract things. All of these things are difficult to measure. Give me things that are tangible as well.
Finances.
Finance, money. What else? I'll tell you some of these other funny things. One thing is sex. Do you agree with that? Do you agree with that? Do you agree with that?
Agree.
Yes, yes.
So
I'm sure everyone agrees with that, definitely.
another one is in-laws. Do you agree with in-laws?
Nope.
They can influence the relationship so tightly. Sometimes it can even lead to upsurge or downsurge of it. Okay. In-laws. And then also side chicks. I mean, when it says side chicks, it looks like it's only the men. So what should I say?
No, it is only the men, Doc. It's side chicks.
Side partners.
Yes. You can't say it's only the men, please. You don't know. You just came from San Francisco. Go and check their records. Okay. I don't want to use side partner because it doesn't make it nice. You have to say boyfriends and girlfriends because you see, there's a better name they use for it. Okay, I remember in one class somebody said that side chicks or if it's not side chicks, it's side cocks. That's it. So they can also influence the relationship. Okay. All right, let's end it here. Of course, there are other factors, and because you can't list all of them, you write UI. The question is this: which one do you think strongly influences the marriage relationship or can strongly influence the relationship? I know what the ladies will say.
Communication.
In order, I don't think communication makes a big difference, to be honest with you.
It
It's
does.
money.
It's quite interesting the lady is saying it's money.
It is.
Are you sure it's money?
It's love.
It's love. Basically, that's what everybody says, it's love. Love is key. But the question is that if you don't subject this to statistical torture, you cannot prove that. So the beta parameter, the beta one, in this case, the beta is telling you by how much, there's a reason why I'm writing this, by how much each independent variable is affecting the dependent variable. By how much each independent variable is affecting the dependent variable. Okay, so love claims that I can influence a relationship. Communication says, me too, I can influence a relationship. Respect says, hang on, I can also. Money says, hey, you guys must shut up, I can influence a relationship. Sex says, keep quiet, everyone. I can make a huge impact on the relationship. So you gather data, you test, you estimate the results, and then you check whether each one of these is truly influencing the relationship. The value you're going to get, the value you will get will tell you by how much that independent variable influences the relationship. So if you estimate the model, this model, you are going to get something like what I'm about to show you below. You will get something like this. So we still have the quantity demanded and equal to, let's say, 40 minus 5 price. This is how the eventual equation becomes. The equation has got the numbers and the letters, but then the model has got only letters, Greek and English letters. Once you have estimated the model, you know that this 5 is the impact of the price on the quantity demanded. It means that if price should increase by 1 unit, quantity demanded will fall because of the negative. Quantity demanded will fall, but by how much? By 5 times, by 5 units. So if price increases by 2 units, quantity demanded will fall by 10 units. That is 2 times the 2. If price increases by 100 units, quantity demanded will fall by 5 times 100, which is 500 units. So the coefficient in front of the independent variable tells you by how much that independent variable affects the dependent variable. Sometimes that independent variable, you have to take the log of it. Those of you who have a lot of macroeconomic variables, you have to take the logarithm of the natural log of some of your variables. So take note. And when you take the log, the way you interpret it is slightly different. You interpret it in percentage terms. We'll look at that later. So that is how you talk about the independent variable. That leaves us with the last term, which is the error term, the UI. The UI is the error term. The error term captures all unexplained factors, factors that can also affect the dependent variable but have not been captured in the model. Because there are several factors that can affect the dependent variable. Even the marriage relationship we spoke about. The marriage relationship we spoke about. We are not done yet, but there are several factors that can affect that marriage relationship, but which we couldn't capture. So in such a situation, all of those factors are contained in the UI, in the error term. And that is how you address it. But by the time you estimate the model, the error term is expected to be 0. So that is why you can see that here I did not bring the error term when I estimated the model. By estimating the model, I mean that you have subjected it to statistical rigor. And so now you have an equation. You have collected data, you have established the relationship. And so whatever error that is there, those errors are expected to be 0. One of the assumptions of regression is that the expected value of the error term is 0. So you expect the error to be 0. Now, normally you have to check that assumption to be sure whether that is true. There are several other assumptions that you have to check, okay, to see whether that will work. But the key point is that even if I now bring multiple variables apart from the price, you should understand how the regression will look like. So I'm going to show you something. I'm going to clear all of these and then show you the specified regression model for our Brucutu data set. This is it. This is how it is here. If we use the coded approach, but please remember that P must have been defined above. Otherwise, when you are writing your model, don't go and use acronyms when you have not defined the acronym. If you are writing your model, if your variable is quantity is who knows his dependent variable? Which of you here knows your dependent variable? What is your dependent variable? Who can tell me? Who is here? Who knows your dependent variable?
Can you repeat the question, Doc? I didn't get it.
I said, which of you knows your dependent variable? The one of you sent me your Excel. Who was that?
I don't know that
Yeah,
is, Doctor. I was about to say for myself, I think it would be the bank performance measured. I don't know if measured by indices would be the correct way of doing it, but yeah.
You are
The
estimating
productivity
what?
itself.
Efficiency or productivity, which one?
Yes. Productivity. Yes, we could not change the wording.
In this case, productivity becomes your dependent variable.
Yes.
Mojaji.
Mine is performance, Doc.
Exactly. But we had something representing that performance. In your reading, I showed you multiple things that can be used to represent the performance. What were they?
Return on equity.
That becomes the dependent variable.
Yeah.
So when you are writing your dependent variable like this scale, if you are writing like this scale, you will write ROA. If it is a cross-sectional data, ROAI. That is how you write the dependent variable. This is how you do it. This is how you do it. That becomes the dependent variable. So that you don't just, you got to write it in such a way that whoever is reading, at least the person will have a feel of what you are trying to indicate here. So I've given an example for some of the, if you have DE efficiency, for those of you who are doing DE efficiency, I have some couple of examples here. This was with a paper that I once upon a time actually wrote. Okay, and this was my productivity. Those of you doing productivity, I had already explained what PI is. And remember, I had collected data over time. So I wrote product PI. Then I come down and come and write where PI is the productivity level or productivity index. Okay. Then I indicated that this is dependent on whether the company is life insurance or non-life insurance. That's a beta one. I brought the I, brought a T, indicating that it is changing across individuals and across time. So you collect data for each bank or each insurance or each country, whichever one you are doing. And then you also collect it over time. Then I have credit risk as another variable, leverage as another variable, the log of total assets. I told you that some of the variables you have to take the natural log. GDP, and I know one of you is doing GDP. So GDP becomes one of the independent, it changes over time. It doesn't change across individual company. That is why there is no I. Inflation also changes only over time. It doesn't change across individual company. That is why there is no I. Then pure technical efficiency, that changes across in each company. Scale efficiency changes across each company. Regulation is one regulation. So regulation changes rather over time. It doesn't change across individuals. And then the error term, in the panel regression, the error terms are many. I talk about it later. So this is another example of a specified regression model. Now let's go back to our own. So that is it. So in your own, if you don't want to confuse the reader too much, I would have used something like quantity supplied. Okay. You write quantity supplied equal to, because it's a cross-sectional model, beta naught plus beta 1 price. You write a full name, price, then bring the subscript. Then plus beta 2 complement. So you write complement. You see, I'm writing it in full. Then after that, you bring the subscript I plus beta 3 income, because that is the M, income. Okay, subscript I plus beta 4. If you are doing the proper regression, okay, you will not use these ones because these ones we were using them because we're dealing with Excel. But if you are doing proper regression for proper analytical sake, you use Stata, you use MATLAB, you use Python, you use R. In that case, you use the dummy variables, the actual names of the dummy variable. You will not code them. And so you would have said beta 4 location because the dummy was location. Then you bring a subscript I plus beta 5 occupation because that was the next thing. Okay. Plus beta 6 religion. So you write your religion. Okay, and then bring your subscript. And then finally plus your error term. So this is how you would have specified a regression model in your work. in your work. Guys, I'm talking about in your work. So you would have written this, you take it to your Word document for you to appreciate it even more. You would have written it like this, you know, and you would have moved it, you would have written it actually into your, where's the Word document? Into your Word document here. Let me delete this. You would have written that first of all before you even come. This is how you would have written your methodology section. You would have written it there. And how would you have written it? You would have gone to insert and then chosen equation editor. I'm showing you a lot of things there. Chosen equation editor here. And then you would have written it using proper equation editor. Hold on. So you would have written it as quantity supply, sorry, quantity demanded equal to beta naught. So you click up here, you choose this number with a subscript. So you write beta, go up there, select the Greek letter for beta. Okay. So you select this beta, then you write subscript 0. Then bring your plus. Then you can copy this beta, paste it, and change this subscript 0 to 1, and then write your price. Then do plus. Okay. You paste it again, change it to 2, write your complement. This is in your work. Plus, paste it, change it to Peter Frey. The next one was income. Oh, but wait. You're supposed to bring the subscript I. So you click here at the top, you indicate this, you put this whole thing for it to look very professional. Quantity, then you bring I at the bottom. Okay. If you are doing IT, you can do comma T. I'll just leave it like this for now. Then we dealt with the price, right? So let me just do it for the price. Sometimes you have to just copy it and then paste and edit. Okay, so I will not do the time again. It's just I. So you have to go here, change all of these to price. You have to, this thing can take your time if you don't start early. You must have started early. Okay. And then you change this one. We dealt with complements, all right? So let me just enter the complement. So that was complement. So you just change this one to complement. And then we also had income. Okay. So you type the income, and then put in subscript I, then plus, can copy and paste this and then edit. Let me now remove this one. Yeah. You can change this one to beta 4. After income, the next one was location. You can do location and then I. Then plus beta 5, change it. After location, we had occupation. So you do occupation, then I, then plus You know, change this to beta 6. And then the last one was religion. So you type this. This is a cross-sectional model. Okay. So you can now, so what you've done is that you've written your model. You can make it bigger, you know, if you want to make a point. Okay. If you want to make a point, you can make it bigger, you know, or smaller, whichever way you want. This becomes a proper regression model. And then you can now explain, you know, whichever variable that you want to explain, because location is split into what? Into 0 and 1, where one is urban, and then 0 is rural. Occupation is a dummy variable which has levels of teaching, fishing, and then trading. Religion has levels of Christian, levels of Muslim, levels of Buddhism. So all of these, you then explain it in words. So this is a model that must be written before you actually go and estimate other things you want to estimate. Now, so you remember you formulated the model first. Okay, you formulated this model first. After formulating the model, before you go and run the regression, okay, you go and run the regression. So now that is what we are left to do. I'm still going to use this baby thing, this simple thing. By the way, so that model, the way it has to be written professionally is not what you see here. So what you see here is different from that model. The way it's got to be written professionally is something like this, which is similar to what I've done here. I think I've not shown the error term, so let me go back here. Never forget your error. So the last thing you have to show is plus, then you insert your error. Don't ever forget your error. Plus, then click here, and then type U, then I. Okay, that is your error term. A regression model without the error term is dead. Okay. So that is how you estimate your model. Let me see if I can save this thing somewhere. That if you ever want, I can then give you. By the way, any questions so far? We're about to end. So you got to start writing your regression model and send to me. You got to start writing your model, start getting your model right up, ready, and send to me. Because if your model is not ready, if the model is not ready, you don't have anything. You don't even have any story. And that is important. Okay. Now, sometimes if you are doing regression with IT, you can do that. But please, for now, I'm just going to remove the IT. I'm just going to make it I, because that's what this one is. So now, assuming we are using Excel, like I said, I'm not going to use R and Python today. But suppose we're using Excel. How would we have estimated this model in Excel? I will still have to come back and come and use this. Okay. To do that, you go to the Data tab at the top. On the far right, you click Data Analysis, and in the list, go down to Choose Regression and double-click Regression. The Regression Parameter dialog box will pop. It's your job to identify which one is an input Y range. The input Y range is the dependent variable. The regressand is the outcome variable. And in this, our example, which one is the outcome variable? Who can tell us? Which one is a dependent variable? Which of you is going to tell me?
You had the quantity there as well.
Good. So the quantity is a dependent variable. So you click on this quantity, okay, you do Control Shift, then you can do arrow down to highlight everything. So I've collected that into the input Y range. Then you click the input X range, the input X range. The input X range is all the independent variables. So click here, drag it all the way to the end, and then Control Shift arrow down so that you get to the end of highlighting everything. That is also collected here. Tick labels in first row, tick labels in first row, and select the output range. And then where you want your results to be, choose the output range. I want my results to be just right below the correlation matrix. Do that, that's it. Okay, remember, I'm using only coded variables. Only coded variables. Then you click OK. So this is going to give you the results of the entire regression, and that's it. This is the entire regression. The decimals are too many, so you can click the Home tab, select the little arrow near General, and select Number to make everything 2 decimal places. That's it. So this is a multiple regression. It's not only giving you price, but it's giving you price and other things. There are so many things you have to interpret and explain here. I will not do that now. Okay. This is where you are going to check whether your variable, your competition is truly, because you see competition is in the list here. You will check whether the competition is truly affecting your performance, ROA. You will check whether your COVID-19 is performing your performance, ROE. Okay. You check whether your digitalization is affecting your performance, or anything else that you are doing. This is where you come and check whether there's a positive relationship, there's an impact, there's a rise and fall and all of that. You get that result. We will explain all the intricacies, everything, p-value, upper and lower confidence interval, statistics and all of that. We'll explain all of this, multiple R, adjusted multiple R, standard error observations, all of this. We'll explain these things later. But this is how you run your regression. Now, when you are done like this, you can take this thing. You see, Excel doesn't give you a very beautiful look of the regression, but the other variables, the other work, they give you beautiful, beautiful, beautiful look of regression. Okay. Let me show you just one that I did 4 days ago on some work that I'm doing. Because that one, I did not use Excel. Okay, I did not use Excel. And usually when you don't use Excel and you use something else like Stata, like R, like Python, you can arrange it very nicely. So look at the way I organize the table. Okay? You have some lovely table. So every variable, you write the full name of the variable, you explain what the variable is, and then the dependent variable, you indicate independent variable, okay, you indicate every independent variable, okay. If some of them are firm level variable, you indicate it. If some of them are industry level variable, you indicate it. If some of them are country level, so as you can see, GDP growth, I explained it, growth in GDP, where you got it from, the source of that data. The log of the variable, you indicate it. Investor promise, inflation. If you take inflation, then explain that this is a rate of inflation, represent the fluctuations in prices of goods and services over time. Where did you get it? The global economy, you indicate it. Institutional investor, you indicate it. CA duality, you indicate it. So whatever data you collected, okay, you indicate it. And then these are a bit of the descriptives that I showed here. See the way I'm labeling the, so this is a summary statistics. You can see the sample size, the mean, the standard deviation, the minimum, the maximum, the median, and all of that. We are here for all the variables. Then the correlation matrix. You can see that this correlation, I have starred. I've put in some stars on some of the correlation. This is a correlation matrix, so it's plenty, it's a lot. And this correlation matrix, the stars here I was able to generate these stars because I used Stata or Python or R, to do that. So it's able to give you the significance of each correlation, where 3 star will indicate that it's significant at 1%, at 0.1%, 2 star is significant at 1%, and then, 1 star is significant at 5%, 2 star is significant at 1%, and 3 star is significant at 0.5%. So you're able to get the significant values for all the correlation. Anyway, so then we come to the regression. See the way the regression have been nicely arranged, okay? Well organized. And then towards the end, you have the intercept, the constant, whether you deal with industry specific, adjusted R square, all of those things, you're able to show everything. There's another regression, there's another regression, there's another regression, there's another regression, and all of that. Sometimes I change some of the regression and take care of some other things. So the one that Excel will give you, like I said, is not too beautiful. However, you can make it beautiful by yourself, or you can use the R to make it beautiful. We'll explain all of this. Very good. So now, if you have a particular question on this very one, let me know. Yes, what do you need to be able to estimate? What do you need first to be able to estimate the regression model? You said you need to understand the data. How do you mean by that? What do you mean by you need to understand the data?
I need to figure out what's your independent and dependent variables, and also understand the regression itself according to the data that we have for using.
Sorry, your line was not good. Repeat. Could you repeat what you said? You need to have your data ready. You need to organize your data in proper columns. Ready. You need to have the data ready. Organize the data properly. You need to do that. Because without the data, what are you running? There are several things you can run, but what are you running? You're running nothing if you have no data properly organized like this. This was just a data for 1 year. And you are getting data for other years. And sometimes you need to also bring as many variables as possible, even if you're not going to use them now. Because sometimes along the line, you get to realize that, oh, I needed to collect data on this so that I can do that. So when you go, get as many variable data that you can get. This is very important. I'm done. We are done. Any question on this? Mojaji, you indicated that today the essence was for me to walk you through the regression. Have you gotten more than you bargained for?
I do talk, but what I just noticed that from the formula that you just did now, there is no alpha. And as from the recording, you said the alpha.
I get you. Alpha, mind you, everything that I've shown you, you can change all the variables. You see, I called my alpha beta naught. You can call it alpha. And then the next one, you can call it beta. The next one, you can call it gamma. The next one, you can call it psi. The next one, you can call it lambda. The next one, you can call it omega. You can use anything. I could have even said alpha naught, alpha 1, alpha 2, alpha 3, you get a point. So these letters are not magic constant. You can change them because eventually they are going to change anyway. They are going to become numbers anyway. Please, does that answer your question?
It does. Thanks, Doc. It does.
All right. So for now, what I want each one of you to do is to write your model. Specify your regression model and send it to me to have a look at it. That means that you know which variables you are going to be using. specify all of the variables of the regression model and send it to me. Because that model is what you will need in your methodology. You need that model in the method. It's very important. Very crucial. If there's no more question, it's been a pleasure walking you through the first half of regression. In the second half of regression, we'll look at some of the assumptions and the technicalities and how to address some of the issues related to the regression.